In the previous videos, we introduced two methods to determine the curtailments of reinforcement in the beam section. This includes the simplified method as well as the Eurocode 2 method. The two methods work out the curtailment of the reinforcement based on the MED per Z envelope diagram, which reflect the tensile force developed along the beam span. The fundamental concept it will be you need to provide sufficient amount of reinforcement bar to resist this tensile force. We mentioned in our previous videos that there are additional curtailment rules that needs to be complied with when you do the curtailments of the reinforcement. In these videos, we're going to talk about those curtailment rules. First, you need to provide at least 25% of the bottom reinforcement bar to be extended to the support with an adequate anchorage length. First is the amount of reinforcement bar to be extended into the support. Based on the amount of reinforcement bar provided, you may do the curtailments along the beam span, leading to reduced amount of reinforcement at the support. However, you will need to make sure those rebar at the support there not less than 25% of what is provided at the midspan. This is what it means by at least 25% of the bottom reinforcement bar shall be extended to the support. And you require an adequate amount of the anchorage length to be embedded within the support. This is illustrated in the diagram here. Let's say this is the beam that you are designing and you have an incoming beam here. This incoming beam serves as the supporting beams for this, and the requirement it will be you need at least 25% of the reinforcement to be anchored within the support, and you should provide sufficient anchorage length to prevent the slippage of the reinforcement. Now, where do you consider the anchorage length? It is calculated on the basis of your bearing area. The anchorage length is counted starting from the interface of the beam and also from the effective bearing regions of the support. Let's say for this case here, the anchorage length should be calculated from here instead of here. So the first rule here carry two informations. You need at least 25% of the bottom reinforcement bar to be extended to the support, and then you need to provide adequate anchorage length. Next is about the requirements of the reinforcement for the end support of various fixity levels. This is summarized here. First, what does it mean by the end support? This will be the end support, where based on the bending moment diagram, you will expect no moment at the end span here. Now, it depends on how you intend to design the structure. There are two types of end support here. One with the fixity, another one with little or no fixity. To make it simple, if you expect the end support here providing little or no contributions in terms of the moment resistance, that means you consider the end support with little or no fixity. Now, if you have intentions to have the end support to carry the moment, this will be considered with fixity. Because of the end support conditions here, the requirements for the reinforcement differs. For little or no fixity, we are looking at the bottom steel bar. The resistance provided should be at least greater than half of the shear force at the support and the amount of reinforcement provided should be at least 25% of that is provided at the midspan. As for the end support with fixity, we are looking at the top steel bar, which should be designed to resist at least 25% of the maximum moment along the beam span. To make it simple, depending on the type of the end support, if you consider it is pin, then the requirements it will be on the bottom steel bar. Now if you consider the end support to be fixed, then we are looking at the top steel bars. The resistance provided are listed here. This is for the end supports. How about the internal supports? Based on the curtailment rules here, the bottom steel bar should be extended at least 10 times of the bar diameter beyond the face of the support, as indicated by the figure here. This is the face of the support, and the bottom steel bar should be penetrated inside at least 10 times the bar diameter if the reinforcements are discontinued. And then you need to provide lapping, meeting the minimum required lapping length. The purpose of doing this is to ensure the continuity and resistance against factors such as accidental damage or seismic forces. Your splice bar should be provided across the support with a full anchorage length on each side. Something like this or this. This is applicable when you have discontinued reinforcement. In normal practice, normally we will extend the reinforcement towards the other side, where we have the reinforcement from the other side extending through the support. With that, we ensure the lapping between the two reinforcements. This is another way to do the lapping at the support. On top of these rules here, you may also adopt the simplified rules for the curtailment, as illustrated here, but with the conditions that the loops are substantially uniformly distributed and the continuous spans are approximately equal. If these two conditions does not comply, you will have to use the fundamental approach, either the simplified method or the Eurocode method, to work out the curtailments of the reinforcement. As for the simplified rules of curtailment, we will discuss about it in the next video.